Let's explore the idea of looking at functions as infinite series, specifically infinite power series. So we found before, for the modulus of x less than 1, if we sum up the terms 1 plus x squared plus x cubed plus so on, all the way up to infinity, that converges to the number 1 over 1 minus x. So a special case of the geometric series. What we want to do is to think of this as a function of x. And in fact, we can use this now to generate new series. So for example, I can now find a series for 1 over 1 plus x squared. How do I do that? If I just replace x with minus x squared in here, on both sides of the equation, I can generate the series straight away. And now with a bit of simplification, this becomes a sum from 0 to infinity of minus 1 to the n, which makes it an alternating series, times x to the 2n. And the convergence of this is for mod x squared less than 1, which is just mod x less than 1. And that follows directly from the series that we used to derive it from. It's customary to write out the first few terms just to see what it looks like. So this will be 1 for n equals 0. When n equals 1, we have a minus 1 times x squared. Next term will be plus x to the 4 minus x to the 6. So you can generate a few series by cunning tricks and manipulations of the initial geometric series that we started with. But in fact, we can do more. We can actually differentiate a series term by term. So let's start with our original example. Then if this works, this will give us a series for 1 over 1 minus x squared. In order to see how to do this with a derivative, let's just write out the series in a general form. So now if I differentiate that just as an infinitely long polynomial, that's relatively easy to do. And we get for the nth term, I can compress this into series notation again, as the sum from n equals 0 to infinity of n x to the n minus 1, which is actually the same as the sum from 1 to infinity because the first term of that is 0. We note that this is just the sum of the derivative of the nth term. So that means we can swap the summation and the differentiation. Because the summation is a linear thing, we can basically take the derivative inside the summation. So that lets us generate even more series. And in fact, we can integrate. If I integrate, this will give me a series for minus the logarithm of the absolute value of 1 minus x. And we won't worry about the constant just yet. I can write this now as an integral of a series. And if I expand this into a sum of terms, I can integrate term by term, which is the same as swapping the summation and the integral sign. And that I can integrate straight away as x to the n plus 1 over n plus 1. And in order to see what this constant of integration, if I take all of the constants of integration, call them c, then at x equals 0, the logarithm of 1, if we just consider x equals 0 in here and here, then the log of 1 is 0 and therefore the constant is 0. So we don't want that. So a series for the log of 1 minus x is the sum from 1 to infinity of x to the n over n. And what I've done there is relabel the series, relabel the nth term with a change of n plus 1 goes to n. And if you write out the first few terms of each series, you'll see that those are the same thing. And so we can generate a whole host of other series from this. So arctan, we know is the integral of 1 plus x squared. We can swap the sum and the integration sign. The minus 1 to the n is just a constant. So the integration that we need to do is of x to the 2n. And we're left with the sum from n equals 0 to infinity minus 1 to the n of x to the 2n plus 1 over 2n plus 1. And note that by using the same trick of looking at the series when x is equal to 0, we can see that the constant of integration must be 0 for this. And the convergence, well, again, we can get that from our original series that we started with, is the modulus of x to 1. So the radius of convergence of arctan, modulus of x less than 1. In order to find out and be careful, we would need to do a convergence test. So now our question is, how do we write a general function as a power series?